Okay, in the last section you learned about classes. In this section we're going to talk about class coupling. What is coupling? In software engineering, coupling is a measure of how interconnected classes and subsystems are. At the beginning of this course, I explained that a software application is composed of many classes that are packaged inside various namespaces and assemblies. In this picture, we have the classes inside an application. Assume that we need to make a change in class A. Now, class B and class F are both dependent on class A, which means if A changes, B and F may have to be changed, or at least they need to be recompiled and redeployed. So the change in A may affect B and F as you see here. But also, class D and class C are dependent on class B. Similarly, class G is dependent on class F, which means changing class A has a bigger impact on our application. And again, you see here, class E is dependent on class D, and class H is dependent on class G. So changing class A affects even more of the application. This is an example of tightly coupled design. So an application whose classes are tightly related or dependent on each other is considered to be tightly coupled application. And this is very bad, because there is a chance that we may break things along the way as a result of all these changes in the application. In contrast to tight coupling, we have loose coupling. So in this picture, I'm demonstrating the concept of loose coupling between classes using a dotted arrow. And this is the ideal software. We want to minimize changes in our application. So when we change a class, we want that change to be isolated. We don't want that change to affect other parts of the application. Now you might ask, but how do we design a loosely coupled application? Well, there are three things you need to understand. The first one is encapsulation, which I explored in the last section. Remember I talked about the restaurant? In a restaurant, we have various concepts, like a manager, like a cashier, a waiter, waitress, a chef, kitchen hands. A waitress does not go to the kitchen and tell the chef how he should chop the vegetables and how he should cook. That's the responsibility of the chef. So the chef has some knowledge and some capabilities. And if you want to model the concept of chef in software, we want to encapsulate all those concepts in a class. So no class from anywhere else in the application knows about details of how things are done in that class. And you saw how we could use access modifiers to achieve that. Now the next thing you need to understand is the relationship between classes, which is the topic of this section. And finally, you need to understand interfaces. Interfaces are extremely important, and they help you design loosely coupled applications. That's why I have dedicated a separate section to interfaces. So let's start with the relationships. In general, we have two types of relationships between classes. We have inheritance and composition. So over the next couple of lectures, I'm going to talk about inheritance and composition, both in terms of theory and practice. And finally, I will talk about the concept of favor composition over inheritance. Composition relationships usually result in less coupling. And that's the meaning of this concept, to favor composition over inheritance. So let's get started.